Hello everyone, my name's Logan and welcome back to the lecture hall. For today's video we are covering common functions that you will need in calculus, and so we're just going to blast through this really quick because I want to get to real calculus rather than just fucking around with some pre-calc and some algebra. So we're going to start easiest functions, linear functions. Y equals mx plus b, where we have a y-intercept at b. That means it crosses the y-intercept, the y-axis at the point b, and then we have a slope of m. So linear functions, cool. Now we're doing power functions. So these are of the form y equals x to the n. So that n can be any number. Let's just say it's 2, we get an x squared. If it's 3, we get a cubic, and it goes up like so. If it were like an x to the 4th, it would be exactly like this parabola, just wider, and so on and so forth. So power functions, anything that is of the form x to some power. Now we have polynomials. Sorry for the dishwasher in the background. If you can hear it, I have to film right now. I have no other time. So polynomials, y equals, or of the form y equals a naught plus a1 to the x times x to the 1 plus a sub 2 times x squared plus blah blah blah, all the way up to a sub n times x to the n, where our a's are constants in our real numbers, and then our x's are obviously our values. These look a lot like power functions, and they're an extension of power functions, and they're going to create some sort of curvy curve that is infinitely differentiable and continuous. Now we have rational functions. Rational functions are just two polynomials divided by one another. So where p of x and q of x are both polynomials, which we just saw, and then they create graphs something like this. There's going to be some asymptotes sometimes because q of x may cause us to either restrict our domain, we may have a hole, we may have an asymptote, whatever it may be. But rational functions are just a polynomial function divided by another polynomial function. Now we have trig functions, so we saw these a shitload in pre-calculus, so I'm not going to cover them too much, but so we have sine of x, and we know it's bounded in a range from -1 to 1. We have cosine of x, which is also bounded in our range from -1 to 1, and then we have y equals tangent of x, tan x, where we have asymptotes at every multiple of pi over 2. And so these are our trig functions. We are going to need to be very comfortable with them. If you do not have your unit circle memorized by the time you're in calculus, we probably have a problem. And I would highly recommend, if you're actually taking a calculus course right now, review your unit circle so that that is in your mind, so you don't have to waste time trying to find what cosine of pi over 6 is. So the last types of functions I want to go over really quick are logs and exponential functions. So they have the exponential functions are of the form y equals b to the x, and that makes sense. Exponential functions are exponent changes. That is our x, our variable changes, and so they are going to grow exceptionally fast. And then we have a log base b of x, and so if we look at it, we're like, it almost looks like if we reflected it over y equals x, they would be the same. And guess what? They are. And we will think to ourselves, now why is that? Well, it is because they're inverses of one another. So we have to think, what is an inverse of a function? Well, that is just replacing our inputs with our outputs and our outputs with our inputs. So the final thing that I forgot to mention with trig, we also have to deal with our cotangents, cosecants, and secants. We see those in some calculus, not too much of them, but those are just our hyperbola functions, reciprocal functions for our trig functions, and reciprocal just means 1 over whatever we had. So sine is 1 over cosecant, so cosecant is 1 over sine, and so on for secant and cotangent as well. And so that is everything I wanted to cover in today's video. It was very short, very brief. Hopefully helpful. I just wanted to blast through this one because I assume everybody knows what types of functions we need for calculus. Thank you. Have a great day.